Hello everyone, I wanted to talk you through this egg lab that we did. It's been fun for me to do at home and I'm so sad that you didn't get to do it at school as we always have a good time with it. If you've enjoyed watching the process, I would love to encourage you to soak some eggs in vinegar and add your own different liquids to it to see what happens in your egg after you remove that shell. So yeah, again on day one we added vinegar and we know the acetic acid dissolved the shell. I also have pictures in here showing you how diffusion and osmosis was working with our iodine and cornstarch. As you can see, the cornstarch is actually the iodine's coming out of the bag and diffusing into the cornstarch. And here the iodine snuck into the bag and was making my cornstarch purple. If you looked at my posts on Google Classroom later, you saw that it got really purple and really dark. And so it became much more prominent than what's shown in here, but you can even see it within these posts as well. So if you didn't see those, that was one process of diffusion. The iodine was diffusing through the bag because the bag is semi-permeable and iodine could move through it, but cornstarch could not. So we were able to see that diffusion process. Well, after the acetic acid dissolved all of the shell on our egg, the next day we were able to feel our eggs and they were quite squishy. So I was able to clean the jar, record their masses and their diameters, and this is what the eggs looked like, okay? So these are their masses after soaking in vinegar. So I do want to point out that their masses increased even though they lost their shell. So if you didn't notice that, make sure you make note of that because that's a pretty big deal, okay? And I want to remind you that vinegar is acetic acid and water. So that might give you a clue if we're studying diffusion and osmosis as to how the eggs might have gained mass after soaking in vinegar, even though they lost their shell. The next thing I want to point out is the next day. So my egg number one soaked in salt water, and my egg number two soaked in fresh water. If you look at the eggs, it's very evident that egg number two got massive. It almost looked like a golf ball. It was so fat. Egg number one also grew pretty substantially. As you can see, they both gained a lot of mass, but it kind of became longer, and you can see that crack is all stretched out, okay? So that happened after soaking in water, which makes sense because, again, we know that water likes to osmose into areas of higher pressure. Okay, so that being said, we saw that on that first day. Now, I did this on purpose. I wanted the eggs to get really big on this first day. And then I added, to egg number two, I added vegetable oil, which I know is less dense than water. And to egg number one, I added corn syrup, which is a whole lot more dense than water. And I want to show you what happens then the next day. So then the next day, it soaked in the corn syrup and the vegetable oil, and oh my goodness, if you can't see this very clearly, I'm gonna blow it up for you. These eggs got so much different in size. This egg collapsed, and this egg got even bigger yet, which is just crazy. I can't believe it got bigger and didn't break, so I'm thankful it didn't break, but it didn't. So we have the egg that was in the vegetable oil got even bigger. The egg that was in the corn syrup collapsed. And then some other really important things I want to point out to you is this picture here. My corn syrup, which is this one, I have more liquid in the jar than my vegetable oil. I want to note to you that I put the same amount of liquid, 200 milliliters, in both jars at the start of this. And yet this one has more liquid in it than the vegetable oil does now. So I want you to think about that and how in the world that's possible. And there's another image I want to show to you on the next page that if we look here, this is the corn syrup, and if you look at it closely, you can see that there's this line of separation showing me what's pure corn syrup and what that extra stuff is that might have diffused into the corn syrup. So make sure you note that. And then I did some extra fun things as well. And so I took that corn syrup and I dyed it green, and then I poured it in a ball jar. And then I took the vegetable oil from my other container and I poured it in the ball jar. And you can see the vegetable oil sits on top, proving that it's less dense. But what's really cool, if you can't see that quite yet, is look, this is my corn syrup. But it's clearly not pure corn syrup because up here it's really dark, meaning it absorbed that food coloring really well. And obviously less dense up here, whereas down here the more dense stuff didn't absorb the food coloring as well, and it's clearly got different densities, so it kind of has this progressive rate of corn syrup. So clearly there's some sort of mixture in there now. No longer do we have pure corn syrup. Also, over here, what I did was to prove to you different densities as well. So I dyed red to be corn syrup, and it stunk to the bottom. And then I dyed saltwater green, and it was in the second layer. I dyed freshwater blue, and notice the freshwater still sits on top of the saltwater because it is less dense. And then I left the vegetable oil, I left it its natural color. And when it was all done, it sat right on top. So it proves that there's different densities here, which might explain why the eggs acted differently whenever they were exposed to the same thing. So I wanted to clarify those things. Something else I want to show you is, let's see if I can get what I'm doing here, is I do have those jars here still. And so again, you can see how clear this is. All down here, that's all my corn syrup. It just looks so crazy different with the vegetable oil on top. And so you can see there's a mixture of stuff that must have come out of that egg somewhere. And then again, here's my dyed jar. This looks beautiful, but you can still see that there are 4 very clear layers, which is surprising to me because I kind of thought the salt would mix in on its own. But I've been pretty careful not to shake it up too much. And then last but not least, really, really squishy and deflated egg, as you can see. I'm going to try not to break it on my computer. And then really full, it would be a bouncy egg. I'm not going to test that right now though. So full egg, squishy egg. Came out of vegetable oil, came out of corn syrup. So how do you think diffusion and osmosis connect to one another? So I want you to think those things through. I did put some questions and extra thoughts on the last slide of our presentation. So in case you missed that, think about it yourself. In the past, I've let students choose what liquids they wanted to add to their lab group's eggs. And so we've had anything from like Windex to antifreeze, and some of our liquids have gone inside the egg and actually dyed the insides of the egg different colors. So I want you to think about that. Like, what kind of liquids would those have to be to end up on the inside of the egg? And then what liquids could you use maybe in your own kitchen that would get it to change color? What liquids could you use to make it super big? Or what liquids could you use to make it collapse? And how in the world does this experiment relate to that cornstarch and iodine experiment we talked about at the beginning? So think about these things. If you want to try the experiment at home and share it with me, or you want to just post any thoughts on these questions, I would love to hear what your thoughts are, and maybe extra effort can earn extra points. Thanks for following along with this experiment with me this week. I would have had way more fun doing it in the classroom with you. Just so you know, the other way we celebrate this at school usually is we spend our week studying diffusion and osmosis, and then the next week we design catapults and we launch it at trees. So if you do it at home, that's a fun way to celebrate. Thank you again, and I will talk to you hopefully soon.